Hey Internet, welcome to the Thermodynamics tutorial. This is a made-up question not found in your textbooks. We want to find the work done on the spring. So we have a spring with a constant of 201 pound force per inch. So that's our K constant. Under a load, which is the force, which is 101 pound force. And we want to find the work in British thermo units, BTU, when the spring is compressed to another 2 inches of displacement, which is X. Step 1, draw your free body diagram. This will help you visualize the problem. We've got a spring, it's compressed by a certain distance, or displacement in this case. Step 2, list all the given variables and find the unknown. We're trying to find work. They give us the spring constant, K, 201 pound force per inch. They give us the force, 101 pound force, and they give us the displacement, 2 inches. Step 3, find the work formula. So work is equal to the integral of force, ds. So if you expand that out, it becomes the integral of the final minus the initial. That's what 2 and 1 represent in this instance. And then we've got our initial force, which is 101, plus the constant multiplied by the displacement, dx, so the change over the distance. Okay, so just note that 2 and 1 means different things when you're integrating different other things, but in this case, for this question, it means the initial and final. Okay, I'm going to assume you know basic calculus for this engineering course. So once you have integrated this formula, you will get this formula. So from this integration, you'll get F0, or it is the initial force, your final displacement minus your initial displacement, and then you add your constant, divide by 2, multiplied by the displacement squared, final, minus the initial displacement squared. Step 4, find the work. So now we just plug and play. So the initial force is 101 pound force. Our final displacement is 2 inches. I'll just put the unit inches on the side. Okay. And then we've got the spring constant, 201 pound force per inch, divided by 2. And we have 2 inches squared minus 0 squared, and that becomes inch squared for the units. So you will get work to be 604 pound force per inch. Now we need to convert that to BTU, so we need to go one more step. So the work, 604 pound force inches, multiplied by the conversion factor, 1 BTU is equal to 778.169 pound force per foot. And then we've got 1 foot per 12 inches. So we multiply these two conversion factors, and we will get 0.0646 BTU, British thermo units. Disclaimers: the method is correct, however, I do make calculation mistakes. I encourage you to solve it yourself and see if you get the same answer. Before we leave, I also highly recommend you save this video onto your PC just in case this video or channel gets taken down. While I follow all copyright laws, sometimes things just happen. You can do this by using snipping tool. If you're on a Mac, you can use the Mac equivalent of snipping tool. So click on the icon in your taskbar, then open up the program. If it's not in your taskbar, go to your Windows search, type in snipping tool, then open up your program. Once you have it open, click on the video option, click on new, left click and drag the rectangle to cover the YouTube screen. This is just an example. Then hit the start button in snipping tool, wait for the countdown, hit the replay button on YouTube, let the video finish, hit the red square in snipping tool to stop recording, and then save your video. So thanks for watching, hope you had a great day. Be sure to like and subscribe, share with your friends because this is a made up question so they probably won't be able to find it. If you got questions, comments, or if you find a mistake in the video, leave it in the comment section. I will get back to you as soon as possible. If you want to support me, become a member or drop a super thanks. Until next time, see ya.